All right, so lesson 7 is on quadratic equations, and I was just saying that how much time we spent on quadratics in Algebra 2, but for you two, that has been, a couple of years, but, really, when you think about it, we had to do a lot of things like factoring and things like that in pre-calc as well. So quadratics are important no matter what type of math class you're in, because even when you go on to higher functions, the things you learned about quadratics still make a huge play. So some of the things we're going to remind ourselves is when you have a quadratic polynomial, when you factor it, like I did here, just using single pairs, and if you set that equal to 0, guys, and you solve them, like the zeros here would be -3 and +1, right? Yeah, right, because you set them equal to 0. So are you understanding why the zeros would be -3 and +1 here? So they can be called zeros. Those also could be called solutions. They can be called roots. They also, if you want to think of it, if you're graphing, they're also the x-intercepts of your graph. So whether they call them zeros or solutions or roots or x-intercepts, it's all the same thing, really. It just kind of depends on, are you in equation form? Are you in function form? Are you going to be graphing with them? But any of these words, zeros, solutions, roots, x-intercepts, they're all referring to the same thing. So one of the ways we would get our zeros was if we can factor it, we would set them equal to 0 and then solve it that way. That was a huge amount of the way that we would solve them, right? So we're really good at the factoring. Okay, and is this the same one?
No, it's the next one. This is reading from the bottom.
Okay, this is just going through what I just said. So in this case, it's the same problem though, isn't it? Okay, so this is just reminding you again, whether you call them zeros, whether you call them roots, because on this one, guys, it's set equal to 0 now. So now I can call them roots. I've honestly been of the idea, I don't care really what you call them because they all sort of mean the same thing.
The next one calls them intercepts.
And they're intercepts here because now we're going to be looking at the graph. So if we're going to be looking at the graph, then we can refer to them as x-intercepts, which brings us to having to keep in mind that every quadratic can be written as a product of two factors. It's just that not every time will it be two real solutions, two real factors. Because, for example, this quadratic right here, does that even touch the x-axis? Mm-hmm. So that's not going to have a real solution. But if you remember from Algebra 2, we can get two imaginary complex solutions. We can always solve for x. Whether they're real or not is another matter, okay? We know that from Algebra 2. What we've never done before, though, is when we've been able to factor, what has been in here has always been real. Real here and real here. And in fact, I don't even know if we ever went beyond rational numbers in there. I think we always had nice rational numbers when we factored. I don't think we ever factored with irrational. We could get irrational answers, but they were always from like the quadratic formula and things like that. We're going to learn today that we can put them in these sets of parentheses, whether they're nice rational answers, ugly irrational answers, or whether they're even imaginary answers. We can factor them.
Factor your imaginary numbers.
Yeah, we can. We can do all of them. Okay? It's just you've got to remember, if the parabola is like this, no, it doesn't have any real answers, but it has two imaginary ones. So I can make two imaginary factors. Might take me a little bit longer, but we can do it. What happens if it just touches the x-axis?
There's only one.
Yeah, like in this case, this must be a perfect square then, because it only touches once. In fact, can you tell me how this factors? Don't you need your attention?
X plus 1. So
Quantity,
X plus 1 squared.
quantity squared. And so you can see the 0 would be what? What would make that 0?
-1.
And so you can see why it just touches there, right? Okay. So when they're real, and especially when it crosses at a nice integer, we're used to factoring things like that, where they're real and integer and nice and easy. Okay, that's nothing new there. Okay, but they don't always just touch once. Most of the time they cut through twice, but even if they cut through twice, we can most of the time factor those. Pairs method. What's two numbers that multiply to be -3 and add to be +2?
3 and -1.
+3 and -1, right? Which would make your two answers or roots what?
-3 and 1.
Okay, is that where these two happen to cross?
Yeah.
Did they?
Yes.
Oh yes, I was looking at that red line being the axis. It's the axis symmetry, isn't it?
Confusing.
Yep, okay. So we're used to factoring the real stuff, okay? All right, there's a lot going on here. I think you all should remember the axis of symmetry is a vertical line. What are the equations of vertical lines though?
X equals
And x equals just the number, right? So like back here, guys,
-1.
this would have been x equals whatever
-1.
it goes through, in this case, -1, okay? It always goes through the x coordinate of the vertex. What is the vertex here? This. Okay. Just wanted to remind you, I personally don't use the axis of symmetry all that often, but just in case, you never know, you might want it for something. Whoops, did I go ahead too far? Okay. All right, this is worth looking at. Let's look at the next sentence. It says the coefficients of the first two terms determine the shape. Well, I think they're talking about if it's in standard form. Okay, this is something we should know a lot about. The a in any kind of a function. Okay, a out in front. That tells us everything about any kind of function. Think about the sinusoids we've been graphing. What does that a out in front do?
Amplitude.
So it vertically stretches or compresses, or if it's negative, flips it upside down. Doesn't the a do that with all functions? So that's going to determine possible reflection, vertical reflection. It's going to determine either a vertical stretch or compression. We know that about a. A does that for every kind of function. Okay? All right, now the B, that has a different job. The B is being added on to that first term, right? So the B's job is more, and it's not as clear because you can't just look at the B and know exactly how much it's going to slide, but the B has to do with sliding left or right. But you can't just say, oh, it's going to slide B to the left or B to the right. It's not that easy in standard form, but it has to do with moving it left or right, okay? And then, guys, the C,
Translated up or down.
well, in a way, yes, but we can even get more specific. The C has a more specific job.
It's new x-axis where the point starts.
On the x-axis?
That moves it
It's
to
actually,
line on the y-axis.
it's the y-intercept. Whatever the constant term is where the parabola crosses the y-axis. Which, that's kind of nice to know that. Because for most problems, isn't the y-intercept your starting point? Okay. So, you were right when you said if you're gonna change the constant term, that is gonna move it up or down then. If your last term was, say, a 5 and you change it to a 7, isn't that gonna move it up? All right? And then if you're gonna change any roots or answers, that's gonna obviously change where they cross the x-axis then, right? Because aren't roots x-intercepts? So if you change those roots, guys, that's gonna change where they cross the x-axis. Does that make sense? So that could maybe make them wider, it could make them skinnier, it could do lots of different things, couldn't it? All right. Now, this is actually my favorite form. Standard form has its place, but if you were going to have to graph, we learned in Algebra 2 that vertex form was the best.
But we did that in Algebra 1.
Not in Algebra 1, no. The V's, the absolute value function, looks almost like that in vertex form. You might be remembering this. Yep, and we do it again in Algebra 2.
Yeah.
But the V, don't they look almost the same? The only thing is, this makes a V. If you change it to parentheses squared, the V becomes a U. So you're right, we did this in Algebra 1.
It's kind of funny because the
do we
V
do it?
lines are straight.
Yep.
And it's like
What
that,
the
like,
squaring makes the V curve because it goes up faster.
Yeah, and it's like in brackets.
Yep.
And it's curved.
And actually, the two are very similar because your vertex for the V would be wherever you slid horizontally, and then wherever you moved vertically, HK. And isn't your A the stretch? Well, guess what your vertex is here? HK. And what does your A do?
Stretches it.
Remember with a parabola, we always would go 1, 1, 2, 4, because we're squaring, 3, 9, 4, 16. But if your A is changed, you have to multiply those numbers by whatever your A is. Where with a V, you just kept the same constant slope. You didn't go 1, 1, 2, 4. You did whatever you did the first time because it was constant. So yeah, you remembered this from Algebra 1. That's great. And then we just changed it slightly and we've got a parabola. But if you have to graph, this by far is so much easier to graph because, well, the vertex is right there. And then we just do the stretch or compression, maybe a reflection.
V's are easy.
Yeah, you're true. Yep.
Super quick, how to spell McLean? Is it 2 C's?
No, it's one C, one little C. And then,
M-C.
Bethany.
It's McLean, not
It's like
McLean.
Cassidy's shirt.
Yep.
Big L.
if they spelled it right.
Don't throw it on
yeah,
paint.
it's
Right in the paint. Okay,
It's McLean, not McLean.
okay.
Like they did for the football cards.
Mine are all capitals, so okay.
Okay, so guys, we actually have a third form we haven't talked about. We talked about standard form, which all three of these are in. We talked about vertex form, but we haven't talked about factored form. Factored form is where you just factor them and leave them in that form, okay? So they want us to change the standard form into factored form and vertex form. So the factored form should be easy. Didn't we factor this one already?
We do have to graph
Do we?
later on.
Okay, so what was this one in factored form again?
X minus 1, X plus 3.
Okay. All right. Now, it's changing it into vertex form that you have to do completing the square on. And did we refresh our memory on completing the square? I know we did in pre-calc, but we've done it earlier this year, right? So guys, the A has to be a 1, which it is. Is that minus 3 anywhere
No.
near the correct third? So we're just gonna add that over here for now, right? We're just gonna move it to the other side. So I have y plus 3 plus, remember doing the boxes? Kaylin's having nightmares right now. She's like, not completing the square!
I don't need
Forget the boxes.
She's like,
I always
no!
forget where.
And then here we have x squared plus 2x plus box.
1
You take 2 divided by 2, right?
and square.
And square it. You get 1 squared. 1. So y plus 4 equals what quantity squared?
X plus 1.
Alright, and then you just move the 4 back. So in vertex form, it's x plus 1 quantity squared minus,
4.
which if you'd have to graph that, that would be super easy to graph.
-1 minus 4.
Does it ask for the vertex?
No.
Okay. But yeah, you're already on your way to graphing it, right? Okay, so I'm just gonna circle, here's factored form. So we started in standard, went to factored, and there's vertex. All right, now the second one. I think we had factored that, wasn't that our perfect square?
Yeah.
Well, guess what? Not only is that in factored form,
That's also in vertex.
it's already in vertex form. I love them when they're both. And then the last one here, I don't know if we've done this one, have we?
No. You couldn't.
You can't factor it, can you? Well, we couldn't factor it before. This would be one where if we had to solve it, and I'm going to check, but I'm pretty sure in the calc book they want us to factor it even when they're imaginary answers. Okay, I'm going to double check that though. I don't want you doing it yet, but I know we have to do it eventually. This is lesson 7, right? Okay. You just check. Yeah. Let's see here. Yes, okay. So, here's what we're going to do. Did they actually put it in then, or how did they? Okay, I guess I'm going to do it this way. All right, so it doesn't factor the normal way, right? Right, guys? So if we were solving this in Algebra 2, we would have been using the quadratic formula by now, right? Well, do you remember it? X equals opposite b, plus or minus square root, b squared minus 4ac. All I get is a smirk. Not even a peep out of you. Better know it. I should.
Right now, pop quiz.
So, before we can put these in, we actually have to find the roots to put them into the factors. So, opposite of b is
-2.
plus or minus square root of
4 minus 4 times 1 times 3.
all over.
2.
2.
Are we writing this down? It's an interesting way of writing things down.
Wait for you to finish.
Oh, you're the Tyler Culzer of the calculus class.
Somebody has to be.
That was Tyler's thing in Algebra 2.
Hey, at least
I'm
you.
just trying to absorb it first.
At least I'm you and writing it down like a third of the class.
Third, yeah.
I know they're gonna take all the possible time they can to
What are they
visit those
doing?
4 businesses. That
Yeah, what are
they're-
they doing? Yeah, like,
They're judging.
but have we ever done that?
This is something new.
What do you mean judging? Like,
Like
you're
We're gonna give them
stuff.
prizes.
They decorated their.
they're decorating.
Yeah.
Okay, I was like, judging what?
The decorations. I think it's good. I mean,
Oh.
okay. And then underneath the square root sign, guys, 4 minus 12?
-8.
Okay, and then it's over 2 and over 2, right? So we get -1 plus or minus
2i,
square root of it.
2i,
Well, square root of 8 is 2 square roots of 2.
and then it cancels with the 1 on the bottom.
Well, that wouldn't be 2i though. It'd be square root of 2i, right? So our two roots are this.
Kind of gross.
So we got to put those in the parentheses. Now, I want you to think about this for a second.
You add 1 and then.
Right, because the first thing is a -1, right? Pretend this wasn't here. So if your answer was -1, you would need x plus 1. You always need the opposite of the root, right? So you need an x plus 1 on both of these to start. Because both of these answers start with this. And then what you need is one of them's going to have a plus square root of 2i, and the other one's going to have a minus square root of 2i. Do I care which one goes where? But this sign has to be plus on both of them because this is a -1 for both answers. So that the factors have to be opposites. Okay, does that make sense? All right, so there's my factored form for the imaginary. That's the worst part of this whole thing. Now doing the vertex form will be much easier. So what was the original?
Y equals x squared plus 2x plus 3.
Okay, do I want that 3?
No.
Move it to the other side. Add a box. Isn't that just going to be a 1 again?
Yeah.
Yes.
But this time you're combining -3 with +1.
-2.
And over here, it's not x minus 1 quantity squared.
Plus 1.
And then we add the 2 because obviously it moved up, right? So your vertex form is the quantity x plus 1 squared
Plus 2.
plus 2. Make sense? So this will be the worst part. And it's not even that bad because you know how to do quadratic formula.
Quadratic formula is my favorite.
You love the quadratic formula? It does come in handy.
I don't have to think when I do it.
What about this one? It already tells you they're going to be complex answers.
Like,
No?
oh, quadratic.
Quadratic formula. So x equals opposite of b.
We should be able to do double pairs.
This right here tells you factoring's not going to work. So x equals -3 plus or minus the square root of 9 minus,
4 times 2 times 2.
okay, all over.
2 times 2.
All right, so that becomes -3/4 plus or minus the square root of what over 4? 9 minus 16, negative, okay. So that would be -3/4 plus or minus,
Just go to 7i.
okay. Now I wonder if they get rid of the over 4 or if they just leave it. They just leave it, okay. So our two parentheses will be, now guys, that's a -3/4, right? So I gotta have an x plus 3/4 on both of these. And then you just put one with a plus square root of 7/4 side, and the other one will have a minus. I don't care what order that's in. But the beginning two have to have pluses because both answers had a negative here. So it's not so bad. it looks really, really ugly, but it's actually really, really easy. Does that make sense, guys? Okay, so we got one graphing, or is there another page?
Oh yeah, you have graph.
Okay,
On the other side too.
so you want a sticky graph.
Bethany tell you she wanted to use it for a bunch of sticky graphs in 8th grade.
Who?
Bethany.
No.
She pulled them out. She's like, I got these too.
What is,
From our homework, we had to make the graphs and stuff like that.
oh,
And she's
Yeah.
like, I got you, man.
yeah, great.
8th, like,
8th grade, coming in handy.
Hulu. Haven't used them since, but
Now, guys, what form is this quadratic in?
standard.
Okay, now you've got two choices. We could complete the square and get this in vertex form, but that'd probably be a lot of extra work. If they're in standard form, you can do this instead. You have this little formula right here. That's the axis of symmetry. That's where the middle of the parabola is when they're in standard form. That'll give you the x coordinate of the vertex, right? So opposite of B,
5,
opposite of B,
oh, 8,
8 over 2 times A.
-4, -2.
Okay, so your vertex is -2 something. How would you get the something?
Would you take the C term divided by the 2?
No? Well, the C term is my y-intercept, so I could graph that point. I know my parabola is gonna go through there, right? And your axis of symmetry is at -2, right, Tony? Oh, thank you. Our axis of symmetry is here. What is the job of the axis of symmetry?
Cut it in half.
It's a mirror, isn't it?
You could plug the two in.
Right, but if I've got this point because of the, can I just mirror it over here?
Sure.
The axis of symmetry is a mirror, right? And then you said plug the -2 into the function, right? And get the y? Let's do an f of -2. Okay, what's -2 squared?
Is the y-intercept supposed to be a -5?
Oh, thank you. I did +5. Thank you. It should be at -5.
So the other one should also be.
Yep, so I'll reflect it over here. Oops. Okay, let's just try that again. Thank you. All right, plug in the -2. So you get 4 times -2 is minus -16, so plus 16, minus 5. 8 minus 5. I'm getting 3. Okay, so your vertex is at -3. -2, 3, I should say.
It should be positive.
+3. Good grief, and I'm in trouble with. Now, guys, do you remember the 149, right? But you have a stretch of what? 2. So your 149 becomes -2, because I'm timesing by -2, -8 and -18. So I'm going to go 1 down 2. And I bet this is over 2 down 8, isn't it? And is that all we have room for?
Yeah.
There you go. Now you could have completed the square and done the vertex form of this same thing, but I don't think it's worth it. Because you can get them done just as quickly.
They're just sitting out there.
Who is?
Yeah, the cord.
Outside?
No, like
chairs, those little.
Oh, they didn't bother to go back to class?
Go fight
I'm
Dawson.
sure they probably said, you don't have to.
I suppose.
Dawson just missed a whole nother lesson.
Yep, was that the last problem? No, we got one more. Well, let's look at it.
Yes, what do you think?
We got the
That's
graph.
cool.
Okay, so guys, you're supposed to find the quadratic equation if these are your zeros. We just work backwards. If your 0 is -3, then didn't the factor have to be x plus 3? And if it's +2, the other factor is x
Two.
minus 2. Okay,
Plus 3.
and the y-intercept is +3, but we don't add +3. These are the zeros, that's all we have, okay? So what we're gonna do here is we're going to, the y-intercept is +3? Oh, okay, okay. What we don't know is what the stretch was. Okay? Could have been a stretch or compression. So first thing I would do is I would multiply out this. That's gonna give us what? X squared
Minus 2x.
plus another 3x would be
5x. What?
1x minus 6. So you get ax squared plus ax minus 6a, right? And on this side, guys, all I know is in standard form, I'm gonna have ax squared plus bx, but what did it say the y-intercept was gonna be?
3.
Okay, and we're gonna run out of time, so I wanna finish this. Even though we only have this last problem left, but you've got 2 unknowns yet. We're gonna have to do a system of,
There's 3 of them.
no, not really, it's just an A and a B.
Oh,
That's unknown.
yeah,
But we'll have to set up a system of equations and then I'll show you how to graph this one. So, we'll finish this up tomorrow. That way, Dawson can then take his test and I'll work out okay. But if you get a chance, I would start some of the assignment.
I'm happy to it's trick 9 that I used for tonight.
Right.